continue. Worksheet 16C, we already found internal forces. Stress is 4.hk caused by Fx, Fy, and now we continue with Fz, 3 kips. So let's draw that cross section again. Cross section is a square 6 inches for each side. So you also have you see Z and you see Y and you see point H and you see point K, point H, and the force Fy 3K, 3 kips going down as you can see there. So it will be here Fy 3 kips, and by the way this is Fy 2 kip and this is Fz, not Fy 3 kips. So the neutral axis is the one perpendicular to the shear stress. In this case, as you can see, the neutral axis go through here. You see the neutral axis, and for that reason, the outermost fiber, the transverse shear stress caused by this internal shear force, it will be 0 at the outermost fiber. In this case, H is the outermost fiber, so that is 0, and K go through the neutral axis. We'll get the maximum transverse shear stress. So that one we have H here, and that is tau. In this case, it will be follow Z direction, and in x-axis, so tau xz equal to 0. Okay. Okay. So okay here. We have tau xz was in Z direction, and it also VQ over IT, VQ over IT, and it's exactly the same at the due to Fy, as you can see there. So the block that we are looking at is outermost fiber, so that one either the top or the right. All right, so that one here, let me do that, delete here. So that one we have, and the Y bar is from here to the centroid, so it's exactly the same because the that 6 inches, and also here 6 inches. So from there we can plug in, and in this case it negative going down, as you can see here. So plug in the V equal to 3 negative, and then this Y bar, this is put down here Y bar, and this is A apostrophe outward areas, so it will be 1.5 outward area 6 times 3 divided by the I, the same 6, the width, the depth of the beam or the shaft or the rod, 6 cube over 12, and the thickness at the K for the beam in here, that is 6 inches. So from that it equal to 0.125. That answer negative 0.125 KSI, and on tau xz. Then we continue with the next two, which is the bending moment about Y axis and about Z axis. So we have the stress caused by My. We have no Mz. My equal to 33 keep inch, and with that, as you can see it on edge, it will be maximum because at outermost fiber, and K go through neutral axis, no normal stress. So that one here, my 33 keeps inch. 33 keeps inch. So we have at edge, as I say, maximum. So let's draw that out so we can visualize. So this is H, this is K, this is H, and this is Z, and this is Y axis. And the moment about Y axis, it actually go that through here. So that actually the neutral axis are there, neutral axis. So as you can see here, this is H, it will create maximum normal stress at the outermost fiber, which is H, and 0 at the neutral axis, go through the neutral axis, in this case K. So we have H, it equal to sigma X, and that my over I, and that m is 33 times Y is from neutral axis. So in this case, as you can see, from neutral axis to here, that is 3 inches. 3 inches. So we have time 3 over I, 6 times 6 cube over 12. From that one, it equal to 0.917 KSI and in tension. And at K, like I say, K go to the neutral axis, sigma X equal to 0. The last one is stress. Let's move to the next page. Stress caused by mz, and mz equal to 30 gives inch. And what is mz look like? We can draw the cross section again, and this is H, and this is K, this is H, and we have that is Z, this is Y. And let's see how my here, my rotate in the negative Z axis, or negative moment based on the right hand rule. Okay, so that it go from there, and that is my, and this is mz. That is mz you have here. So let that is mz. And from that we have neutral axis is go through H in this case. This is the neutral axis, and the stress go through neutral axis equal to 0. So as you can see from H, sigma is also sigma X, because the normal perpendicular to the surface, and the surface divided by the axis perpendicular to it. So it means the X perpendicular to the base or string that we are talking about. So it will be 0. And K is outermost fiber due to mz with the neutral axis at shown. So we have sigma X equal to, and as you can see, with that direction of moment, K, it will create at K we have a tension normal stress. So you will have my over I, and in this case 30 times 3. So use a lot of intuitive in here. I 6 cube over 12. So the answer it will be 0.833 KSI positive tension. So that we do all of them, okay, all of the forces, and now we just add them together, and that go down here, and of course we can go back to the block later on. So from that we can add all stresses, So with the block we have, so let's draw block here. So blocks can be drawn here. I will draw that back later on. Y, X, and XZ. So block H. H. Okay. And for the direction, question X, Y. Positive X, positive Y, and the other one is XZ. So X and Z. Then we just add them. Let's see what is the normal stress for H. Compression 0.667 tau sigma for H 0.917, so that is tension. So you negative 0.67 plus 0.917, you will get that equal to positive 0.25 KSI in X direction, 0.25 in X direction. So that we have here 0.25 KSI, and that is sigma X, as you can see. Sigma X. And again, tau XY on point H, tau XY negative 0.0883, 0.083, and nothing in here. So from that 0.0 negative on X plane, so it means opposite of you see the positive X plane on the left, and it negative opposite Y direction, so that will go this way, and of course that will be go that. So that is 0.0833 KSI, and that is tau XY. That's what you have. And then for K, sigma X. For first one, negative 0.667, nothing for sigma, and then 0, and positive 0.33833. So from that we subtract, so we have the sigma X here, and that equal to 0.167. Sigma X 0.167 KSI, and then we have tau, and of course no sigma Z, tau XZ, nothing for K, XZ negative 0.125, nothing. So negative 0.125 and it's negative on the positive x, so it will be opposite in the x, so it will be in the positive x-axis, so it's opposite, go up, so it will be tau xz equal 0.125 KSI. And of course, with that we are done, and then we can go ahead to plug that into our answer up here, so that to complete the question in here, so you can quickly write down this is for x 0.25 KSI and tau 0.0833 KSI, and this one is x sigma x 167 KSI, and tau xz and equal to 0.0125 KSI. And with that we complete the problem, and believe it or not, this is the last problem before we, of course, you practice for the final exam, but the last problem we have the video. Good luck everyone.